Okay, so today we will start with a new unit. If you recall, last time we learned a new data structure called the stack. And the stack, it has a feature called last in, first out, LIFO, etc. So stack is also used to store a number of items, okay, in the format of last in, first out. And we also discussed some of the applications using stack. And you also understand like the runtime stack, is it in operating systems also using the concept of stack. And also now we also understand recursion. And how recursion works, it's also because of the runtime stack that it can keep track, okay. So anyway, so stack is a kind of data structure. So far we already know array can be used to store a number of items. We also learned array list. In Java, that it can also be used as data structure to store the number of items. Okay, then we also learn stack can also be used to store a number of items. Is it? And for array and array list, both have the advantage of indexing. Is it? And it's the indexing, then it's very benefit for faster retrieval. Okay, and for stack, then its feature is we can access at one end. Is it? So it has the advantage as the last in, first out. Okay, so fast access all operation, is it, on the top end. So that's regarding stack. So what today we will learn another new kind of data structure. So all we discuss here is regarding data structure. Or sometimes we also call it container. And all of those are linear. All this we discuss in linear container, linear data structure, okay? Because they can all be viewed one by one, like in a line shaped kind of, is it? So that's why we call it linear, okay? And the new one that we will learn today is called queue. So queue concept, we are all in ordinary life, we are all quite familiar with the queue concept, okay? Like the grocery store, checkout lane. Is it? So you need to stand one by one, kind of, is it? In a line, is it? So here is the checkout, is it? So whoever come next, then they need to stand at the end in the line. Whoever is the first, then they get their turn to do the checkout, is it? And then the line keep moving, is it? So that's what we call checkout lane. And also for the airport, etc. So airport, we also follow this kind of like checkout lane, etc. So there are a lot of cases in ordinary life, is it? But if you really think about this one, is it? This one is you enter at back, is it? And you leave at front. And the verses, if you recall, stack. Stack is you enter and you relieve. So we enter and leave both at top, only one end, is it? But here you enter at one end and you leave at the other end. So enter basically it's add, is it? And you leave basically it's remove, is it? So here enter means we add and we remove, is it? So basically for this checkout lane is we can access both ends, is it? So here it's front and back, is it? But we add at back and we remove at front. Okay, so that's the concept. Okay, that's a concept. Okay, and so then regarding this kind of situation checkout lane, etc. So we add at back and we remove at front. So to describe this kind of data structure, we can use a new concept. We call it queue. And based on that checkout lane, the queue has a feature not LIFO, is it? It's a first in and a first out, is it? So first in, first out, so FIFO. Is it FIFO? First in, first out. Versus stack is LIFO. Last in, first out. This is whoever first in will be the first out. It's by turn. Is it? No advantage. This is by turn. Okay. So if we wanted to describe the data stored as first in and first out kind of feature, then that data structure is called a queue. Okay, a queue. And the queue can allow you access both ends. Okay, so this is general queue concept. Okay, and then next let's see what are the operations that is important to queue, is it? For queue, is it? And if we recall stack, we discussed two major operations, push, is it? And pop. Those two operations regarding basically it's for adding and for removing, is it? And then similar, is it? For queue, so normally when we discuss data structure, what we care about their operations is you add new item, you remove item, and you retrieve item. Those are the major operations that we care about for data structure, etc. So then for Q, the same thing, etc. When we say we add new item, here only add back, etc. So for Q, generally speaking, we give it a new name, we call it in Q operation, okay? And when we say, okay, we want to remove front item at front, is it? Then that kind of operation, we call it DQ, okay? D and Q, so it's a verb, okay? It's a verb, DQ. And just think about, generally speaking, for Q, we care about front item, is it? Because you're going to remove it also, is it? So normally we also interested in retrieve front item, is it? So normally that operation, we just call it a front operation, okay? So that's the major operation that we are interested also regarding a Q, okay? And then what is the next important part? If you recall, when we implement stack, the implementation, we discussed using array, is it? But of course, it's not just limited with array. You can also implement in some other data structure, okay? And then the similar concept, okay, for Q, we are also going to discuss our customized designed Q, okay? And the Q, in just like a stack in Java library, it also has the respective container that you can use as a Q, okay? So here we first understand how are we going to implement. So we discuss its implementation. Okay, so we discuss the implementation. We also start with array concept. Okay, so let's see how we use array to simulate a queue. Okay, using array to store queue. Then assuming, okay, so assuming over here we have an array, and the array has some size, is it? That's everything. Okay, so we are going to discuss Q implemented using array. Okay, using array. So let's first visualization. Okay, how are we going to? And assuming this Q, the array's capacity is 6. Capacity is 6. Okay, so here's sub 0, sub 1, sub 2, sub 3, sub 4, and sub 5, etc. And we assuming the name is called, suppose, M array. M array, okay. And suppose it's integer. Okay, it's an integer. Okay, so it's an array, etc. And we are going to use it to store items for Q, etc. And for Q, we need to keep track of both front and back, is it? So in this case, then we need the index for front item and also back item, is it? So that's what we need. Okay, so then let's assuming, okay, the first number we want to add is 100. Okay, so where are we going to add? We are going to enter at the first spot, is it? And this is a front item, is it? So we use the index M front, then it's 0, is it? It's 0. And we also need to keep track of the back item, is it? And generally speaking, for the back items index, we don't use the last item's index. We use the index that is beyond the last one. The last one. Okay, we're using that index. Okay, so then in this case, that's called, we call it M back. Is it? Then M back should be 1 in this case. Okay, and then we add the second 200. 200. Front won't change, is it? But the back index is going to be changed. So it's going to be updated to what? To 2. Is it pointed to here, to 2? And then we add 300. So 300 is added, is it? Front won't be changed. So the back index is going to be changed to 3, is it? And then we add 400. Is it? So front that index won't be changed, but back index is going to be changed to 4. Is it? Same thing, we are going to add 500. And the front index won't change, and the back index need to be changed to 5. Is it? And if at this point, can we add another one, 600? Basically, we cannot, because if we add 600, then the back index is out of the array's index range, is it? Because array index range is 0 to 5. Okay, so this case already means that the queue is full. Queue basically is full. Is it? Is full. Okay, and so now we cannot add. Based on what we just saw for the add operation. So basically this is in queue operation. Is it? For in queue operation, what it occurs, what it happens is each time when we add a new item, that M array sub M back, that specific slot is going to be assigned with some item. Is it? Then you update your back index by 1. Is it? Move it to the next one, update it, increased, increment by 1. Is it? So this is incremented by 1. Okay, that's how this works. And then, so we understand how in-queue works. Now it's full, we cannot add. That is full, so no way to add. But we can remove that. So next, let's see, how are we going to remove? So we want to remove, and we want to remove 100. If you recall for stack, basically you cannot wipe it out from the array. There is no way here, is it? The only way you can update is what? Is the index. So what we want to remove 100, then the index is changed to 1. Is it changed to 1? That's the front index changed to 1. okay? And if we want to remove 200, okay, then the index is going to change it to 2. Is it change it to 2? So we can keep doing like this. Is it? Okay, so now you see, we remove those 2. So now we basically have more space we can add. Is it? And if we wanted to add, so now we have space for new items. But the question is where we add. We add here 600, but we add here the index updated to say that's still not working. Is it? So no, that won't work. Then if you really want to make it work, you need to shifting. Is it? You need to update. Okay, move 300, then move 400, then move 500. Then we need shifting. Is it? After we shifting, then all this front. Each time when you do shifting, the end front is going to be updated. Same thing. We need to update. So when we do shifting, it involves updating both M front and M back. Is it? For this simple, just the single digit or hundreds of array items, it won't be a huge work, is it? But think if you have millions, and each time you need to do this, add a new item, remove it, you keep doing this kind of shifting, it's a lot of work. Is it? So it's not going to be efficient with this kind of shifting elements, is it, within the array. Okay, so this concept works, but it's not efficient. Okay, so let's see. Then the question is, can we have some better way to deal with this heavy shifting, really lift this kind of shifting work? Yes. So the previous way that we described, basically the concept we use is linear array. Is it a linear array? So you just store them in an array that's linear distributed. Is it? And then with linear array, it involves shifting. The shifting is unavoidable. Okay, it's unavoidable. Is it? So there are a lot of shifting we needed to handle. Okay. So this is not efficient. Not efficient. Okay. So then the idea, can we change the way we think? Okay. So let's see. Let me redraw. So suppose I rewrap. Suppose your linear array is kind of like some string that you can bend. Then we can redraw that array circular way. We can do this. Is it? Then this is sub 0, sub 1, sub 2, sub 3, sub 4, and sub 5. Okay, and this is still my array. Is it? And the capacity is still 6. Okay, so you view it like that. That's okay. Is it? That's perfectly fine. That's how we think logically. But of course, on heap, it's still going to be on memory, machine's memory, it's still linear. Okay, there is no warp way. Okay. Okay, so, oh, sorry. How can I get rid of everything? So let me redraw. So we just change the way that we think. So we have sub-0, sub-1, sub-2, sub-3, sub-4, and sub-5. Is it? So now let's see. So initially, the front is 0. Is it? Okay, and basically initially the back should also be 0. When the Q is empty, we initialize both at sub-0. Now I add 100. When I add 100, we previously said we let the back index point to the one after it, beyond it. So this should be incremented by 1 and be moved to 1. Is it be moved to 1? Front is still at sub-0. Okay. Then we add 200. After we add 200, back index updated to 2. Is it? Okay, we can keep doing. Then we add 300. Then the back index is 3. Then we can add 400. So back index can be updated to 4. Then we add 500. Then back index updated to 5. Is it? So back index is 5. We have the empty slot. Is it? And we said previously, we also said now the queue is full. Queue is full. Okay, because we always maintain an empty slot, okay, between front item and back item. Okay, we always need to do this. Okay, later on I will explain the reason why. Okay, now this is full. And if this is full, I want to remove now. Okay, so let's see the scenario. So I remove 100. So 100 is gone. Then the back in or front index is changed. So front index updated to 1. Is it? And I can remove 200. After I remove 200, then front index updated to 2. Is it? Okay, now let's see. Now I want to add, suppose 600. Where can I add? Oh, of course, you can add here. Is it? 600. Okay, I add 600. The back index, by previous, it's +1. +1 is 6, but we don't have 6. But in this case, we don't need to shift. Is it? We can set back to 0. That works. Is it? It's just suddenly jump from 5 to 0, but it's still continuously. We don't need to do any of the shifting. It's a continuous sport here. Is it? And how do we jump from 5 then to 0? Is it? So let's consider this case. The capacity here of the array is what? Is 6. Is it? And my back, so m back is 5. And I do increment, then its value lead to 6. 6 is out of the range of array index, but if I do 6 modulo 6, I get what? I get 0. Is it? I get 0. Then I wrap it back to 0. So you see this module operator, it's very powerful. As it can bring it back to 0. And for all of the remaining, let's see, 1 module 6 is 1, 2 module 6 is 2, 3 module 6 is 3, and 5 module 6 is 5. And then when you do 6 module 6, it's back to 0. As 7 module 6, it's back to 1. Keep doing. Because whenever you module 6, you can only get value 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5 is what? It's index value. So if we borrow this module operator and apply it to all of our index, then it won't hurt. Is it? And it also take care of this wraparound from back, from the sub 5 and all the way back to 0. It take care of very gracefully. Is it? There is no shifting needed. In this case. Is it? So now you're back to 0. Is it? If you keep adding, okay, 700, then you're back, you just plus 1. Is it? And then module 6, it's still get you back to 1. Is it? So it works perfectly. We can keep doing like this. Is this? So we don't need to worry shifting anymore. Okay, it's just when we think about this array, we think it this circular way. But when we handle it, is that we just use that module operation to handle it. So this concept is new. Is it? This kind of array, we call it a name. We call it a circular array. And so in programming, when we deal with it, nothing changed, still as usual. Is it? It's just we use this special module operator to deal with index. Okay, so using module operator to deal indexing, to deal with its index. That's it. Okay, that's it. And then no shifting needed anymore. Okay, so it's much more efficient, very smooth. Is it? This kind of circular array concept is a very neat concept in computer science. Okay, it can help us deal with all sorts of this situation whenever it involves with the wrap around. Okay, wrap around. Okay, so over here, then we can use a circular array to deal with it. Is it? And let's come back to see when we have a circular array, then the front index can be greater than back index. Is it? In the previous linear way, we cannot do that. But with circular, then, because in this case, the front index, in this case, is 2, and the back index is 1. So back index is less than front index. So it is still allowed, okay, when we use circular array concept. Okay, so be careful here. And then let's see. So it's kind of messy here, is it? So back index is 1, is it? And if we keep removing like 300, 400, 500, 600, 700, after we remove everything, we will see the front index then it's going to be bring back also to 1. Is it also to 1? So we can see if we use a circular array to implement our Q, then the Q empty condition is what? Is the front index is equal to back index. Is it? When both are equal, no matter where it is, if both are equal, then that means your Q is empty. Okay, and in this case we just discussed, that's the Q already full, is it? And what's the full condition? The full condition is what? Is if we take a look here, is it? So if the back index plus 1 and then module the capacity, if it is equal to the front, is it? So back is 1, 1 plus 1 is 2. 2 module 6, you still get 2. Front is 2. So if both are equal, then that means your Q is full. So that's why we need to keep an empty slot, because otherwise if we don't keep it, is it? If we don't keep it, then that's go back and the front are the same. Then that's the empty condition. So there is no way to differentiate empty condition and the full condition. So that's why we maintain an empty slot. Then we can differentiate the empty condition and the full condition. Okay. Okay, so that's all of the basic concept, here. Okay, and then let's first remove everything. Okay. Then let's get back to see how do we do the coding with the circular array. Okay, we can start from the very beginning with the circular array. Then we have sub 0, sub 1, sub 2, and then sub 3, sub 4, sub 5, etc. And initially, when the Q is empty, etc., at the very beginning, M front should be 0, and M back should also be 0. So this is where M front is and M back is it? Okay, then let's see. When we add 100, then M back updated to 1. So basically it's plus 1. And then when we add 200, then it's going to keep updating, is it? So then it's updated to 2. Does it keep doing like this until what? Okay, then 300, 400, 500, then M back is 5 here, is it? So each time when we do the in-queue operation, what happens is the back index, is it, increment by 1. But if you recall previously, we see after we remove, then it's jump back to 0. Then that won't work, is it? So the back index should be updated with what? Then module capacity. Then this will take care of all of the case, including you jump back from 5 to 0, is it? But whenever we do in-queue, the first thing we need to do is we need to fill out the empty slot with whatever the item we have, is it? We assign it to that empty slot. Then we update the back index. Okay, so that's regarding in-queue operation. And then we can do remove, is it? Okay, we remove 100, then the front index plus 1, updated to 1. Is it? And we remove 200, then it's plus 1, updated to 2. And front. Is it? Keep updating. Is it? So that's DQ operation. Is it? So for DQ operation, whenever we do that, what happens is the front index got updated, increment by 1. But after it's increment, but it may happen here. Is it? Jump back to 0. How can we avoid that cases? We can always do module capacity. So then that won't cause any trouble here, as it will always make your front index between 0 to 5 within the range, is it? And then like in this case, we add 600. So 5 plus 1, then module 6, let's bring back to 0. Is it? Then we can add 700. Is it 700? Then the back index updated to 1. Is it? Pointed to this empty slot. Is it? So that's regarding DQ operation, how we can handle using circular array. Okay, using circular array. Okay, and with array for the DQ, then we don't need to do anything. It's just like a stack. Okay, so this is the general idea about how are we going to implement in-queue and DQ. So what is the most important operation now is this module capacity, is it? Okay, then next, let's see. So right now, front is here, back is at 1. So front greater than back, is it? And how are we going to do item by item visit? Is it? Suppose we want to output Q from front to back. Is it 1 by 1? How are we going to do it? Using the regular loop. So for integer I, then this time not from 0, it should be from front. It should start from front 2. And then the index, is it how are we going to, when are we stop? We stop at the back. Normally we say, okay, I less than 1. But here, the back is even less than front, so we cannot do that. So the termination condition is, okay, we loop until it's not the back index. Is it? If it's not. If it is, then we need to stop because there is nothing here. But then the question, how are we going to increment? If we just do I++, that won't work, is it? Because once you reach 5 plus 6, then 7, that won't work. So the increment part, we need to change it as I+1. Then we do module capacity. Then problem solved, is it? So it can wrap back from 5 to 0. So this part can wrap it, can take care of from 5 to 0. It will take care of that special cases. Okay, so when we do want item by item from front to back, then we can use this loop. The loop termination condition we need to change. and the loop increment condition, we also need to change. Okay, then that will work. Okay, so this is the discussion regarding all of the working mechanism when we're using circular array. Okay, and then next let's discuss. So regarding Q, that so here we want to design a Q data structure. Then just like a stack, is it? We can use a UML diagram. Is it? And for UML diagram, what we have the front index, so it's integer, and the back index is also integer, and we also have that array. Is it? And it should be hold with a certain capacity. Is it? And the type, assuming in our case it's integer. Is it? And they are all set up as private. Okay. And the operation that we care about, of course, constructor. No doubt about it. Okay. And we also care about what? That in-queue operation. And with in-queue operation, you're going to add some item. So it needs a parameter. And the return type should be void in this case. Okay. And we also discuss the DQ. And DQ just like a pop. It doesn't involve any item to plug in. So it should be empty. Okay. And we just change the index. So the return type, we can also make it as void. And we also care about the front item. Okay, front item is get operation. Both of these two are set operation. And this is get. The return type should match the array type. Okay, so that's why it's integer. Is it? And you may have some other operations, suppose like generally we also provide the toString. Is it? So then toString, the return type should be a string. Okay, should be a string. And maybe more operations. Oh, the empty condition check. Is it? That should be a Boolean type. And maybe you also have some full condition check, a Boolean, and more operation. Is it? So this is the UML diagram regarding Q, is it? And once we have this UML diagram, then we can start our coding. Okay. Okay, so that's so what today we discuss is all about the Q concept. Okay, and if we want to implement it using array. And conceptually, how are we going to do it? Okay, so that's all for today. I don't